If every single human vanished today, what would be the last light left shining on Earth? You might think of street lamps, glowing cities, or even solar panels. But the real answer is far stranger, darker, and hidden where almost no one would dare to look. Because while most of our world would fall into darkness within hours, a faint and eerie glow would survive for centuries. And it's not where you think. The systems and keep fuel flowing. Without people, that entire process breaks down almost instantly. Coal and oil plants would be the first to fail, running out of fuel or shutting down automatically. And when those dominoes fall, the rest of the grid takes the hit. Power stations everywhere would overload, one failure triggering another until the world plunges into a rapid cascade of blackouts. In just a matter of hours, the global skyline, the lights of our cities, the glow of our homes would vanish, leaving behind a planet far darker than we've ever known. At first glance, nuclear power seems like it could keep the world glowing for decades. A single cube of uranium holds millions of times more energy than coal. In theory, reactors could run almost endlessly without refueling. But here's the catch. Nuclear plants are built to shut down the moment something goes wrong. Every system is designed with one priority: safety. If power is lost, if a sensor malfunctions, if anything drifts out of balance, the reactor doesn't try to keep going. It slams into emergency shutdown. And without humans around to monitor, adjust, and maintain them, those shutdowns would happen fast. Hours, maybe days, but never decades. So while the fuel is there,
If any modern machine was built to outlast us, it's the wind turbine. Unlike coal plants or nuclear reactors, these towers don't need constant babysitting. They're designed to spin on their own, catching gusts of wind high above the ground. In fact, history has already proven how tough they can be. One of the earliest large-scale turbines in Denmark ran for 11 years straight without a single maintenance check, and it kept generating power the entire time. Modern turbines are even sturdier, often rated to last several years with no human care. Some could keep their blades turning for decades, powering tiny lights or control panels long after cities have gone dark. But even these giants aren't immortal. Deep inside each turbine, hidden in the gearboxes, the same silent enemy waits: friction. Without oil changes, without repairs, those gears will eventually grind to a stop. Sooner or later, every turbine will seize up, and the wind will pass them by. If there's any power source built to endure, it's hydroelectric. Massive dams like Hoover Dam are designed to run almost on autopilot, harnessing the endless flow of water to spin their turbines. In fact, operators have admitted that if everyone simply walked away, the dam could keep generating power for years without a problem. But here's the twist. Even if the turbines keep turning, the electricity has nowhere to go. With the power grid already collapsed, all that energy would be stranded, surging with no homes or cities to light up. And over time, the dams themselves would begin to falter. Intakes would clog with debris, turbines would wear down, corrosion and mechanical breakdowns would slowly choke the machinery. So while the roar of water might echo for centuries, the glow of hydroelectric lights would fade much sooner. Even Earth's largest powerhouses would eventually be silenced. After the big power plants fail, only the small survivors remain. Battery-powered lights would flicker for a short while. Flashlights, emergency lamps, even backup systems in buildings. But batteries have a built-in countdown. Even untouched, they slowly drain themselves dry. Within a few decades, every battery on Earth would fade to black. Solar, however, tells a different story. Scattered across the world are off-grid solar panels powering weather stations, satellites, and even roadside emergency call boxes. These systems don't rely on fuel trucks or human operators. As long as the sun keeps shining, they keep working. And if nature lends a hand, occasional rain washing away dust or breezes clearing off debris, these panels could last astonishingly long. In dry climates, with well-built electronics, solar-powered lights might glow steadily for 100 years. For a time, it would be these lonely solar beacons, silent call boxes, and forgotten stations that shine as humanity's last reminders in the dark. But the true last light of humanity isn't solar, wind, or hydro. It comes from something far more unsettling: our own radioactive waste. When spent nuclear fuel is sealed away, it doesn't just sit there silently. Deep underground in glass blocks and concrete vaults, something strange happens. As radioactive particles move through water or glass, they create a faint, ghostly light known as Cherenkov radiation. It's the same eerie blue glow seen inside reactor pools, a glow born from energy moving faster than light can travel through water. Among the most haunting examples are blocks of cesium-137 waste. This material has a half-life of 30 years, which means it keeps glowing faintly for centuries. Even as its brightness fades, the color never changes. The blue remains, soft but unyielding, long after every other light on Earth has gone dark. And so the very last glow of our civilization won't come from shining skyscrapers or solar call boxes. It will come from toxic blue light, hidden deep in vaults of radioactive glass, our final, unintended beacon to the empty world we've left behind. In the end, humanity's final lights won't be the dazzling skylines of New York or the glowing streets of Tokyo. They won't be solar panels quietly shining in the desert or dams humming beside rushing rivers. The very last light we leave behind will be something far darker, an eerie, toxic glow buried deep beneath the earth. Radioactive waste, sealed away in concrete vaults, still shining with the ghostly blue, long after our cities have crumbled.